All right. So, talking about volumes of revolution. Sorry, forgot to typical. All right. Um, so the first method we're going to talk about today and tomorrow is called, it's really the washer method if there's not a hole in the middle of the disc. Okay. And then next week we'll start talking about the shell method. Okay. So what's happening? Okay. Don't write any of this down yet. Okay. We're talking about uh, an area. Okay, we know how to find the area of this region. Okay, if we draw horizontal, vertical rectangles, we would take f of x minus g of x, right? Okay, well, what we're going to do is we are going to rotate this around the x-axis, okay, until we get something that looks like that, all right? So we're just going to take this and we're going to rotate it around, and it becomes this really cool 3D figure. Okay. Okay. Well, you saw when I got there. Yeah. Right? Okay. So there you go. Okay. Just like with area, we're going to break these up into infinitely many rectangles. Okay. Except this time we're going to work with discs and washers. All right. So we're going to break this up into rectangles, and we're going to call this thickness dx, just like we did with our area. Okay. What we're going to do is we're going to take each of these rectangles and we're going to rotate them around. Okay, there's these really small, really thin rectangles, and we're going to rotate them around so we get a bunch of discs and or washers. Okay. So see how some of those have holes. Okay, this is why we're calling it the disc method. Alright. Okay, so first of all, how do we find the volume of a disc? Just a disc. Just a disc. Okay, what's a disc? It's like a circle, right? Okay. Right. But if I'm just talking about like the top surface area, how would we find that area?
Pi r squared.
Pi r squared. So if we're talking about a disk, we're talking about pi r squared. Now, what happens if we have a washer?
The outside circle minus the inside circle.
Okay, we're going to have to talk about the outside circle minus the inside circle, right? So, basically a pi r squared minus pi r squared. Now, if we're talking about the volume, we're going to have to multiply by what?
By
the height, right? Okay. Okay. So, the volume of our washer is pi r squared minus pi r squared, where the pi r squared that comes first is going to be our outer radius, or our biggest one, okay, minus the smaller radius, okay. So what I've done here is I pulled out pi and I put h at the end. Okay. Now, how are we going to relate this back to my picture of a bunch of washers going around and around?
calculus.
Sorry. I was asking a question, but I didn't understand.
That is great. Okay. Okay. So, here's the formula that we just figured out. Okay? Now, if we're talking about this region of area that we're going to twist around, okay, instead of r squared minus r squared, okay, we're going to talk about the furthest away function minus the closest function, okay? And instead of height, okay, Well, if you look at this washer right here, the height of this is our delta x. Okay, it's our dx. So then what we're going to do is we're going to add all of these washers together, right? Okay, well we have an infinite number of infinitely small washers that we're adding together. Okay, let's think back to when we learned about integration. What did integration mean?
Sum of
Okay, we took the limit of the sum as our rectangles got smaller and smaller and smaller, right? And an infinite number. Okay, so our volume is going to be represented by an integral. Okay, because we want to add up all of these really small things. What? Here it is. This is what matters. Right here. This is our washer method. Now if it's a disk, if there's not going to be a hole, what do we not have to worry about?
the height or the
We don't have to worry about subtracting another function. Okay? Now, you are not going to memorize this formula. You are going to think about this formula. Okay, if I'm going to use the disk, how do I find the volume of the disk? And you are going to think about how you find the volume of the disk when you set up each integral. Okay? You're not going to memorize the formula. You're going to think about it logically. Okay? We're going to do some examples. For each of these, I do want pictures.
3D pictures?
As best we can. I'll show you what I want. Okay? First example, write it down. Okay, and we have our three functions written down. Okay, today we are only going to rotate over horizontal axes. Okay, tomorrow we'll worry about what happens when we have vertical. Alright, so instead of drawing on my PowerPoint, I'm going to bring this up so I can draw better pictures, okay? Alright, so what do we have? We have x equals 0. That, right? Okay. We have y equals x. And then how do we graph x minus 1, the quantity squared, plus 1? What is it?
Parabola.
It's a parabola that has been shifted up and right 1. Okay. Okay. So what portion are we talking about? This right here, right? Talking about this yellow portion right here. Okay? So what we're going to do, we're going to take these little horizontal rectangles, and we're going to vertical rectangles. We're going to rotate them about the x-axis until we get a picture that looks like this. Okay. It's creating a volume, creating a 3D figure. Okay, this is the exact thing that was animated in my PowerPoint. You remember that very first animation where it was spinning around? Okay, it's this right here. Okay, so let's think about how we find volume. First of all, we have pi, because we have pi r squared h minus pi r squared h. Okay, and our h is just dx. Okay. Now, we've labeled this as we're integrating with respect to x, so what are our limits of integration? 0 to 1. Okay? Our outer radius. How long is our outer radius? It's our top function to back to the x-axis, right? So what is that top function? So here is our outer radius squared. So here we have pi r squared. How did I determine what? Okay, so I am rotating about this right here, right? We're flipping along this axis. So from my top function to my axis of rotation, that is that function. Just like we were finding area. Right? Okay. And then my smaller radius, this is creating a hole right here, right? So we need to subtract. What's the small radius? So x squared. That's calculated. I want this answer in terms of pi. Brady got 23 pi over 15. Agree or disagree? A majority of the time, that's how your answered choices are going to be. Now, if it's like on a multiple choice, more than like sometimes they'll be in terms of pi, sometimes they'll be decimal approximations. Right, and then you can just multiply by pi. Okay? Can you get that? Okay. You can work with your calculator a little bit. Okay? Again, be really careful with the parentheses. Because we have the quantity of the quantity exponential squared plus 1. I don't have to look at it. I've never. Okay. Oh. Next problem. right, do we have this written down? We have y equals the square root of x over 1 to 4 about the x-axis. Okay, well this is nice. We only have one function, don't we?
Yeah, we do. The discs.
A bunch of what?
Discs.
Here is our function y equals the square root of x. And we're talking about from 1 to 4, and we want to rotate it about the x-axis. 1 to 4. I wrote 1 to 4, but said something else. I'm sorry.
No,
Okay? So, first of all, we are going to draw in our rectangle, and we're going to rotate these rectangles about the x-axis until we get something that looks like this. Kind of looks like a cup, doesn't it? Like a coffee cup sort of. Okay. All right. Volume of discs. Okay, does everyone agree we don't have a hole in the middle, so these are a bunch of discs, correct? Volume of the disc. Pi r squared h. We have vertical rectangles, so we have thickness dx. All right. What's our radius? How tall is that rectangle? Square root of what? Square root of x.
square.
Pi r squared h. All of those rectangles have height of square root of x. Okay. And we're integrating from where to where? This is one I would expect you to be able to do without a calculator. Okay? We have pi integral from 1 to 4 of x of x dx. No. Okay? So we have pi times 1/2 x squared evaluated from 1 to 4. Okay? 1/2 times 4 squared. Which is 7.5, which is
15 pi.
okay, so we have 15 pi over 2. A majority of these I will let you use your calculator. Some of these I still want you to do by hand so you don't lose your integration skills. Okay? Any questions on this setup? When there's no hole and we just have discs, it's going to be a nice integral, isn't it? Okay. This is supposed to be y. Okay, we have a volume formed by x squared and x, and we're going to rotate it about the line y equals 2. So we no longer are rotating around the x-axis, we have a different axis of rotation. It is not going to change a whole lot. It'll just change a little bit of how we find our radius. Okay, first thing we have to do is draw a beautiful picture. Okay, so we have the line y equals x, and then we have the parabola y equals x squared. Everyone agree with my picture? Okay, so we're going to rotate this teardrop looking area around y equals 2. Okay. Okay. So, what is this going to look like? We're rotating. We're going to have these little vertical rectangles that we're rotating around. All right. So, we still need to think about the concept of top to bottom, top minus bottom, when we find how long our radii are. Okay? Everything is always going to be top minus bottom. So, we have discs or washers. Okay? We have washers with a pretty big hole, don't we? Okay. So, pi r squared and our h is dx. Okay? So first let's talk about our outer radius. Okay? What is our outer radius? Okay, what's the biggest radius? We need to go from our curves to our axis of rotation. Okay? So since we're rotating this guy around, we have this as a radius right here, and this as a radius right here. It's any given point. Okay? So this is our biggest radius, right? So we're going to call that 2 minus, the furthest away is the parabola. So 2 minus x squared is radius squared. Minus our smaller radius, top to bottom, 2 minus x. What? The 2 is coming from this being the axis of rotation. We're going from 2 to curve, and then 2 to curve.
So is it always the biggest radius minus the smallest radius?
Yes.
Top to bottom. So first above it, or
Flip it above it, what do you mean?
like since the axis is above all of the whole function, the top, like what would be the top from the x-axis is now like the smaller radius?
Well, we're no longer really worried about the x-axis because we're flipping over y equals 2. Since y equals 2 is higher than our function, we have to start there and then go down. We still are doing the top to bottom, top minus bottom. Okay? Okay? And then what are our limits of integration?
0 to 1.
Now, what if, okay, let's take this same piece, let's take this same chunk and rotate it around a different axis of rotation. Okay? I know you guys can integrate with your calculator, alright? So we're not going to worry about the answer right now. Let's take this around y equals negative 1. So here is y equals negative 1. Okay. Hold on. My drawings are not spectacular, but you'll forgive me, right? Thanks. Now, let's talk about these radii. Okay? We still have these vertical discs that we're talking about, or washers, excuse me, that we're talking about. So we have pi r squared h. Okay, let's talk about our outer radius. Okay, here is our axis of rotation. What's the furthest away from our axis of rotation, the line or the parabola?
X.
Okay, our line. This is the furthest away. So our outer radius, top minus bottom, is what? What's the top function?
X.
X minus, what's our bottom function? Negative 1. So you have x plus 1. Right? Minus our inner radius, okay? Well, the least furthest away is the parabola, right? So, from top to bottom, we have our parabolas first, minus negative 1. Okay. Okay, you need to think about where your radius is, okay? Okay? You want to go from the top to where you're rotating around, and then the bottom to where you're rotating around. So the top is here, minus what you're rotating around. Top minus bottom. So you have x minus negative 1. Okay? And then you want your inner radius. So here to here. X squared minus negative 1. You want that right there. Right, you got to go from top to bottom. So since our function's on top, we go from function to line. But if our line is on top, we have to go from line to function. It's whatever's on top. Okay? Okay? So let me give you what your assignment is. Anything I box, that means do by hand. Practice. By hand. Okay? Take it slow. The pictures are the most important. The picture with that rectangle, it tells you how to find each of those radii. Okay? So if you have the picture, you can tell how long each of those radii are. Okay? You have to do this assignment. You come tomorrow without trying this assignment, you are going to be sunk. Okay. So what we're doing, we're going to do the same thing, but we're going to rotate around vertical, and so it's going to be wide. So I'll add another video. So watch the video, and then you can either write my homework now or get it from me. Okay, perfect. Thanks. Somebody want to hit the light for me?